Hey there, and welcome to Into the Terminal. Today we're going to be talking about GPG keys. GPG keys are effective in encrypting data that sits out on your file system, whether those are RPMs, RPM packages, or just generic files that you have out on your file system. With that said, let's dive on in. So when using GPG keys, the first thing we need to do is to, go figure, create a GPG key. So we're going to use the GPG command, and we're going to use two dashes and gen-key. We're going to give, so we're logged in as Joe. So we'll just say that we've got Joe Smith here. We'll give him an email. And somehow he managed to luck out with joe@gmail.com. Or that works too. And then we want to hit O for OK. So our key is asking us now for a password. So let's go ahead and just put in password for the sake of example. It will balk at that, but we can just go ahead and overwrite it just for the sake of example today. Okay, so we've got ourselves a GPG key created. Now, next step is why don't we export our GPG key? That way we can use that. Excuse me. That way we can share our GPG key with other users, other systems. And so, like Scott has just highlighted here, the last 8 digits of a GPG key are the key ID, and that's going to be important as we go to export the key itself. So let's go ahead and do a GPG export. And then we want to take those last 8 digits of the full ID there, and that's our key ID. And then we want to export it to a file. So we can export it to, say, the temp directory, and we'll just call it joe-key.pub. That will allow us to export our GPG key so other users can import that key. See what we... Excuse me. Got double hyphen...
Make sure that we're referring to the correct key. So list keys will show us what keys are there.
This was totally planned. We're just showing you how to troubleshoot key export issues.
Oh, you know what? I used 9 digits instead of 8 digits.
Yeah, that's very important to keep in mind. It is exactly 8 digits, no more, no less.
I think you can also use the entirety of that string.
That may be easier.
But like a choice between the last 8 or the entire, I know which one I choose. All right.
Okay, so we've now got our exported key out in the temp directory. We'll come back to that a little bit later in the episode. But for the rest of our critical path, why don't we just encrypt a file? We could encrypt, say, SE password if we wanted to grab a list of, if we wanted to grab a list, excuse me, I'm struggling today. If we wanted to grab a list of users, encrypt it, and maybe export that as part of a report.
Right. And we will have to do one more step before we encrypt it, because we need to import the public key of the person we're sending it to. Unless are we encrypting it for ourselves, Eric?
I think for critical path, we'll just encrypt it for ourselves. It's simplistic example, but hey. Sorry, folks. It is apparently allergy season here in Kansas City.
And we can show that this has actually happened, right? Because I can just maybe head the Joe's password copy. This is the plaintext file that we copied.
Mm-hmm.
But if I take a look at Joe's password copy GPG, which should be the encrypted version of that file. Oops, put the wrong passphrase. Go. That is the encrypted copy, but if I just use something like cat,
Mm-hmm.
.gpg, right, it's just encrypted goop. That's what's stored in there until I decrypt it using the GPG, or we could see that Les actually called the GPG decrypt so it could show me the contents of that file, right? Just to show you one more time. So it called GPG, stored my passphrase, and now is able to decrypt content that's been encrypted with my public key.
Awesome. Anything else we should cover in the critical path?
I think those are the key things. Let's take a deeper look in our transition.
Awesome. So, hey there, and welcome to Enter the Terminal. This is episode 38, working with GPG keys. If I survive this episode, it'll be great. I'll grab a cough drop here in just a second. I am, or was, Eric the IT guy Hendricks, and joining me is Scott McBrien. We're switching things up a little bit, trying to get more to the point in the critical path, and maybe hang out and chat a little bit after the transition. So, Scott, do you want to give some background on GPG keys before I keel over?
So first, let me remind you that now is the time of the show where you can put things in chat, and we will address it as best we are able. And then, a little bit about GPG. So GPG stands for GNU Privacy Guard. It is an open source implementation of PGP, pretty good privacy. And the two are actually interoperable. So if you are a shop that uses PGP and you have a PGP key, you can use GPG encrypted files or GPG created keys interchangeably with your PGP infrastructure, and vice versa. The goal is that you have an asymmetric encryption type that is tied to an individual user. So in the critical path, we created a GPG key pair for Joe. And the key pair is two things: a public key and a secret key. And it is an asymmetric encryption algorithm. So whatever is encrypted with the secret key can only be decrypted with the public key. And anything that's encrypted with the public key can only be decrypted with the secret key that matches it. So in another example that we'll get to in a second, we're actually going to trade a file between two users. And so in order to do that, we're going to have to encrypt the file with the user's public key that we're sending it to, because we know that only their secret key can decrypt it back again so they can access it. Another place where GPG is commonly used is on signatures. So basically like validating content. So Thunderbird, as an example, is a mail client that you can install a plugin in for called Enigmail, which allows it to then have GPG support. And so when you send email, it will by default, or can by default, put in a signature block at the bottom. And essentially it like makes a hash and then encrypts that with your secret key, so that when it is sent and the person who receives it opens it up, they'll see the text of the email. And then at the bottom, there's that encrypted block, that signature block. And they can use the public key that they can get to unencrypt it and then basically do the same hash of the content to verify that the hash that was sent in the encrypted signature verifies the hash that they're able to create through their email client. So essentially, they're validating that the content that was sent to them from you is the same content that you actually sent, that it wasn't interrupted, corrupted, or transmuted in transport between the sender and the receiver. You can also use Enigmail to do full email encryption. So that would be like on the sender side, we fully encrypt it, and we would have to have the public key for the person we're sending it to and our secret key. And then we send it to them, and then they can decrypt it by applying their secret key and our public key to get it back to plain text. But that way, as the mail is traversing the email infrastructure, which traditionally is plain text, you're sending an encrypted blob through all these places that could inspect your content. And it's only the recipient who can decrypt it back into text and read the message. So not every mail client supports this. I know, for example, here at Red Hat, we use the Google Suite, and Google Suite does not natively support this. So we would have to use something like Thunderbird and the Enigmail plugin to get this GPG support. That was very
And
long, Eric. Sorry about that.
no, you're fine. I grabbed a cough drop, and I think I may live now, so we're in good shape. uh, Another area where you might often see GPG keys is when adding a new repository to a system. Maybe not.
Oh, too soon.
Yeah. Um, so when you add a new repository, there's usually those lines specifying a GPG key. And you want to finish my thought for me?
Sure. So we at Red Hat actually sign all of our RPM packages with a GPG signature. It works the same way as I described for the email signature, right? We make a hash of the RPM contents. We then encrypt that with our secret GPG key and then stick that metadata into the RPM header so that someone who wanted to verify that this package really came from Red Hat can use our publicly available public key, decrypt that content, run the same hash algorithm, make sure that the two hashes, the one stored in the signature and the one by analyzing the package contents, are the same. And so essentially what you're doing is verifying that the package that you're receiving comes from the place that you are expecting it to come from. Because RPMs specifically like have shell scripts that can be embedded in them and a variety of other things that you're allowing to operate on your system as root. So having that extra validation that it really came from the person you expected it from may be important to verifying the quality of that content and also protecting your system from rogue content.
Awesome. Yeah, I think that was some much needed context around GPG keys. So why don't we dive back into the terminal, pun intended, and let's talk about how we use this in a more practical sense. At the top of the show, we had a single user. We created a GPG key, and so that doesn't do us a lot of good unless we share that key with someone else.
Yeah, so I'm going to use our friend tmux, just split my screen. And I'm going to use the bottom half of the screen as another user. So the top half is my Joe session. The bottom half is another user that we created before the beginning of the show named Mary. There we go. And if we do a command to look at Mary's GPG keys, Eric may be able to help me out with that.
Maybe. So we're trying to list Mary's. It's a --list -keys. That's what I get for this being
Yep.
the first call of my day.
So we can see that Mary has already created a key pair for herself as well, right? So let me show you Joe. Right, so Joe has a key created and Mary has a key created. And thanks to us having both of these keys, the two users can trade their public keys to each other and then can encrypt content that can only be decrypted by the intended recipient. So for both of these people, we put their public keys out here in temp. The file names are a little bit different, but we can do something like a GPG imports on Mary's key. We put there earlier, right? Now if I go gpg-list-keys, now we see in Joe's key ring that he has both his own key and Mary's key. And if we do the same thing for Mary, so she has her own key in her key ring and her and Joe's key that she imported. So quick side note about a little bit more depth. When we do a --list-keys, we're only listing one kind of key, which is why when we imported Joe's public key into Mary's key ring, it showed up. or if we imported Mary's key into Joe's keyring, it showed up. Because when we do a list keys, it's only showing the public key keyring. So there's another option that will show the secret key keyring. I'm gonna like blow your mind here.
Imagine it's a very, very secretive command.
That's right. So list secret keys shows you the secret keyring. So in the case of something like package validation, right, we're importing someone's public key into our public keyring. But we wouldn't have the secret key that matches it because we can't sign things as being from Red Hat because we don't have that secret key. And Red Hat would be very, very sore at us if they distributed the secret key and we got it and we started doing that. So, the secret keys are the ones that you can use for encrypting data. And then the public keys are the ones that you can use for creating the encrypted message for the recipient. So you can't decrypt it back again if you encrypt it with someone's public key. But that also allows this kind of validity of identity to be established. All right, so I've traded public keys for both of these people. What's next, Eric?
So in the top half of the show, we actually encrypted a file using Joe's account and encrypted it with his GPG key, which we now imported into Mary's keyring. So why don't we copy that file over into the temp directory and attempt to decrypt it as Mary?
So what do you expect to have happen if we do that?
So if we use if we're logged in as Mary and we use the imported key, the imported public key from Joe, we should be able to decrypt that file and be able to read it as Mary.
But that's only if we encrypted it with Mary's public key.
Oh, that's right. We didn't copy. That's right. Okay. Yeah, I misspoke. So we need to re-encrypt the file with a key that Mary has access to. Sorry. This is what we get for changing up the lab right before we start.
Yeah. Here, let me go ahead and just remove Joe's copy here so we can eliminate confusion.
Because clearly I'm already confused.
Okay. And then I'm going to go in here and just make some changes, like 50 dB. No, I don't want that many. 10 dB. All right. So now we have like a customized file that's different than, say, Etsy password, right? So we can show that there's no hinky dinks going on. All right, so we're going to GPG encrypt Joe's password copy. Here it's asking, who are we encrypting this file for?
So in this case, we're logged in as Joe. So let's encrypt it for Mary.
Yeah, and there's a couple different ways that you can specify who you're encrypting it for. I like using the email because it's easy to see in the list keys. But you could also use the key ID, and I think you could maybe also use their name. It's been a minute since I've done that. All right. So here's a warning that, hey, if you're going to encrypt it for this person, you really need to know that that's really this person. We'll talk about some trust verification in a bit. Let's see. So it has been encrypted for Mary. And then if I try to less Joe's password copy GPG, it was GPG encrypted for Mary, which means as Joe, I can't decrypt it back again because I encrypted it with Mary's public key, which can only be decrypted with Mary's secret key. So it's showing me all the encrypted goop that's in that file. All right, so now that we've got the file encrypted for our recipient, we're going to go over to that person. And we're going to grab that copy of that file. Right, and there it is in my directory as Mary. And I'm going to do a GPG decrypt. And it's going to ask me for the passphrase that I used when creating my secret key. And then it shows me the contents. So I'm just going to take that, I'm going to save it.
Yep. Yeah, the original command just outputs it to our terminal by adding the greater than sign and then giving it a file that gives it a place to land, so that we can hang on to the decrypted contents of that file.
Yeah, we're redirecting it to a file. And I think, Eric, didn't we do an episode of Into the Terminal on redirection?
Yeah, we had a command line tools episode. I'll dig that up and throw it in the show notes.
So now that we've decrypted and saved it, we have this plain text version that we can just look at or edit or do whatever it is that we need to do to it.
Let's see, what other practical use cases? I think that's kind of the bulk of what we set out to cover today. We did have a couple of questions that I'll send your way, Scott, if you want to play a little stump the chump this morning.
Always, I'm happy to be the chump.
So I guess I could take the first one. So Shantanu asks if we picked the names by accident or if it was on purpose. So admittedly, this episode was a little bit different. We actually had the lab content submitted by someone other than Scott and I. So the show is getting a lot of traction, not only on YouTube but also here at Red Hat. So we actually got a few. We had some folks submit some content for us to use or steal. Oh, you wrote that?
I wrote that.
I thought Peter somebody was. Maybe he was the one who told me about it. I don't know. Anyway, so apparently Scott wrote this. So it was Scott's lab. So we'll have to ask Scott that question.
So I chose these names because they were easy to type. Quite frankly, like that's how I picked them out.
Okay, so there's. I just noticed that. So it looks like our Discord bot is not working today, so I'm not seeing all the questions here. So catching up on the chat here, let me grab one of the other questions here, and I'll see if I missed anybody. So Shantanu, I can't find the question in chat, but in spite of security, why was gpgcheck usually off till date in Yum repos?
So that is probably a configuration setting that was local to you. So we have kept gpgcheck on for all the Red Hat repos for many years. And in fact, if we, hold on, let me go back over to my terminal and I'll go back to single session here. As root, if I do a RPM QA, if I'm going to grab GPG, these are the GPG public keys in the RPM GPG keyring. So when you specify a GPG file and you have GPG key check enabled, it will import the referenced file into the RPM keyring. And you can do a RPM QI, whoops, put the right thing as places, on one of these. And it'll actually show you the GPG key, but let me do that into less. It'll also tell you who issued it. So like when we were making our own GPG key and we put in the real name and the email that goes along with it, like that was stored in the header of the key file. And so you can see that even though this is being managed kind of like a package by RPM, the same contents is in there. So this key that we're looking at is Red Hat's auxiliary key 3. issued to security at redhat.com. So I'm guessing that several of the others are also Red Hat ones. I know that this machine also uses some GCP packages, so I wouldn't be surprised if there were some GPG Google keys in my key ring as well. So I think if you were seeing GPG check was 0, that was a choice made by someone configuring that repo. Oh, and I see that Shantanu has clarified that a little bit on random repos. Yes, that's because maybe they didn't sign their packages with GPG, so you can't check something that doesn't exist. And if there is a mismatch between the GPG key that's referenced in the repo definition and the RPMs that you're downloading from that repo, Yum and DNF will refuse to install them. So it actually does that GPG check to validate the packager before it actually does any of the RPM transaction. And if there is a mismatch, it will fail the RPM transaction and exit ungracefully, telling you that there was a key mismatch. So a lot of people would like copy and paste things and not bother to update the key file, or maybe they're using a internal repository where they weren't GPG signing their things, so they just disabled it to keep that from happening.
Awesome. Yeah, so GPG check, not something I'd recommend setting to 0 for official repositories, just because you never know when someone might kind of sneak in and use nefarious package repositories to pretend to be Red Hat or another organization. So Shantanu also asks, can things like packages be signed by more than one key?
So that one, I'm not entirely sure of the answer. I think, and this is just like based on my experience, the answer I would say is no. So the reason I'm saying that is that I know that when I sign packages as an RPM generator, I use a command called RPM resign that will actually overwrite a signature if it exists in the package file with my own key. So I can take somebody else's, like, let's say I pull a package from extra packages for Enterprise Linux repository into my personal repositories. I can actually re-sign that with my own keys and then only trust my own keys so I don't accidentally pull packages from people. I would only pull packages or allow packages to be installed that were re-signed by me. So I think the answer to that is no, that you can't have more than one GPG signature. But I'd have to do a little bit of internet sleuthing to really feel comfortable and authoritative in saying no.
So maybe.
I think no.
So Dwayne asks if there's any tools for keeping track of keys, and beyond GPG dash list dash keys, nothing really springs to mind. How about you, Scott?
So key management is one of those things that is can be challenging. First, being someone who has lost his keys over the years, that's been a sore spot for me personally. So when we created the keys as Joe or Mary, it created this .gnu pg directory in their home directory. And that's where the actual like GPG stuff is stored for this user. So it's really important that nobody else in the system has access to this directory, because then they could like lift people's secret keys away from them. So that's one thing, is it's actually stored in files. Although you'll notice that when we did the creation of our keys, we applied a passphrase. The passphrase is used to encrypt your secret key. So the secret key just isn't out there for anybody to apply. They have to have not only the secret key, but also the passphrase to unencrypt it and utilize it. It's one of the reasons why you want to use a passphrase protected key, not a passphraseless one. If passphraseless key, as long as you have the file, you're good to go. So you want that two-factor of not only do you need the file, you also need the passphrase that protects it. The other thing is, like, it's really not convenient to trade public keys back and forth with people. So there actually are services for that. Give me a second to look it up here, and I'm going to share a different screen.
So I don't know if you ever partook in one of these. I know I wasn't able to, but back in the day, like around conferences or engineering offsites or that kind of thing, there would be big ol' key signing parties where everyone would bring like a flash drive or something, and right in front of the other person, you'd create a new key, dump it on a flash drive or SCP it between systems. And so you knew that you were in person, you saw the operation, you generated new keys and handed that off. That way, engineers could then go home to different geographies, even different countries, and be able to share files back and forth, just for the sake of knowing absolutely with no issues that those keys came from the source because you watched them do it, and so you knew that that content could be trusted.
Yeah, and so what we're looking at here is a list of keys that have the word McBrien in them from PGP, hold on, pgp.mit.edu, a public key server. So you can take your public key and upload it to the server, and it'll like create a listing here with your key ID and your name and your email, all the stuff from that GPG public key header. And what's important about this is you'll notice that there's several listings for me, but then there's other people like Gary McBrien is actually my uncle. And when you click on one of these, so let me click on one of mine. What you see are those endorsements, those signatures that Eric was just talking about. So for this one, I went to like an all hands meeting and we had a GPG key signing where everyone kind of signed everybody else's key. And typically you like verify their ID. So you are basically putting your stamp of endorsement saying, I have checked that this is the person to whom this key belongs by checking their government ID and other stuff. And remember way back earlier in the show when we encrypted something to Mary, there was a warning that GPG put out that was like, are you sure this is someone you trust? Answer yes or no. And the reason was because there were no signatures on that key. So all we had to go off of was that the name to the key was Mary Smythe and the email address was Mary at Gmail. But like we never had to prove that we owned that account, right? So we just like put some stuff in a key and called it good. So having these signatures is how you actually like validate the authenticity of someone's key. And then the other thing is that GPG keys now are created with a 2-year expiration date automatically. And that's important because you'll notice in my list of McBrien keys here, there's this one. So this one has even more signatures, but unfortunately, I've lost the secret key that goes along with it. So because I made it good forever and I never had to renew it, it'll just sit out here on this key server forever and be confusing to people because now there's 2 keys that say they're mine, but only one of them's actually valid because I can no longer revoke this one. You'll see that if I go back, there is one that was revoked right here. And that happened because again I lost it because I'm really terrible at keeping keys apparently, but it expired, and or actually that one I take back. I revoked that one. The other ones will actually say expired if they've not been renewed by the key holder. So yeah, you want to put an actual like date of expiration on your key, not make a good for everyone like I did. And also you want to put a passphrase, not a passphrase one like I did back in like, the early 2000s when I didn't know any better and made poor decisions.
So the only other question we have on our list is GPG keys part of zero trust security? I think that's a much deeper topic, but the short answer I think would be yes. GPG keys having a sure way of sending encrypted data across the internet from one user to another is a good part of any strategy, whether that's zero trust or just trust. Um, but maybe in the future we could talk maybe on RHEL Presents about zero trust and what Red Hat is doing in that space. But great question. Just a little bit more meat than we've got time for today. But Scott, thank you so much for kind of carrying this episode. I nearly died. It felt like.
Please
But
breathe, Eric. Please breathe.
right. I'll avoid the light, the LED light ring for now. But thank you so much for joining us. Come back next week. I'm really excited to share that we're going to do another episode arc. We're going to do a series of episodes around services. So we've spent the last 38 episodes talking about things you can do on your system, but over the next 3, 4, 5 weeks, we haven't completely fleshed that out. We're going to talk about what you can actually do with your system. You've got all this stuff set up. You've got all these users. You've got security. Now let's actually run a thing. So next week on episode 39, we're going to be building out a web server. So we'll talk about Nginx and Apache. Meanwhile, be sure to subscribe to our channel to get notifications of when we go live. We've got this show every Friday, and we've got RHEL Presents every other week. Be sure to like and share this with a friend if you found this information helpful. Also, make sure to add any additional questions into the comments. We're pretty good about checking those every day or so. With that said, thank you so much, Scott, for joining me and walking us through GPG keys. And on behalf of Scott, myself, and the entire Red Hat Enterprise Linux team, thank you all so much for joining us, and we'll see you next time.
Bye, everyone.